Well, thank you for that kind introduction. So with that, I'm very excited to get into this, so let's get right into it. By way of agenda, I want to introduce to you the subject of biotics. Simply, why are we even talking about this? And then, of course, we're going to get into the 4 different area of biotics that we have to talk with you today about. We're going to talk about, how we define them. We're going to talk about modes of action and certainly evidence or data that support each one of these biotic areas. And if it feels a little bit deep and heavy during this time, especially for those of you that may not be as technically oriented or more focused on the commercial side, please bear with us as we go through the deeper realm, because we're going to be a bit like a submarine going deep, and then we're going to come up to periscope depth, take a look at the lay of the sea, if you will, with some applications. And I promise you, if you hang in there, it'll be worth your while, because I think there's some real world applications out of this really pretty profound area of scientific research. All right, so with that, why do we want to study the area of biotics? Well, simply put, the name alone, the definition of the name alone makes it obvious. I mean, biotics means pertaining to life in the Greek. And so if we really want to enhance the health and well-being of these fine animals, we would certainly want to concern ourselves with biotics and what they could do for the health of the animal. The way us and our dogs, our cats, our horses are designed is in a very symbiotic relationship with these microbiota. The microbiota that inhabit our intestines are not there, as parasites, if you will, but rather they are meant to be there, and they confer a symbiotic or a healthful benefit, especially when they're in the right level and the right types in that intestinal environment. And thirdly, as far as reasons why we would want to study these biotics, keep in mind that the microbiome, which is basically the name for the total environment, what's in it, what they're doing, the things that they're producing, how they're interacting with that host, the microbiome is a very dynamic system. It's plastic, it can be changed and modified. And this is perhaps the most important point I'd like to make of the whole presentation. So think about this, that, in contrast to the genome, which is primarily structured or set at the point of conception, the microbiome undergoes changes throughout the life of the host, during stressful conditions and other situations where it can be changed, and oftentimes, sadly enough, for the detriment of the host. So concerning ourselves with how we can modify that microbiome is very, very important. So please take note of that point. The fourth area of why we would want to study the biotics is due to their effect on the host immune system. This is foundational to what is going on with the animal. And finally, it's not just about what happens in the gut. What happens in the gut does not stay in the gut. Rather, it affects other systems of the individual. So whether it's the gut-brain axis, the gut-skin axis, or the gut-lung axis, or anything related to this, there are many different effects of the microbiome that happen outside of the intestinal tract. And, some of these are a little bit catchy terms, but we're going to go into discussing them a little bit more in detail, so you really understand what is meant by, for example, the gut-brain axis. All right, so I put this next slide together to talk to us about the biotics, presented as an overview. We're certainly going to get more detailed about what each one of these biotics are as we walk through this presentation, but I wanted to wrap it together from the beginning so you get a kind of an overview or a lay of the land of how they relate to one another. All right, so the one in the middle is probiotics. These are the seeds. Now is springtime, at least in the northern hemisphere, where people may be planting grass seed, for example. And analogous to that, with probiotics, we're purposefully putting live organisms into the gut, which seed the gut and help it move in a certain direction, of hopefully a beneficial direction. To the left is a prebiotic, which serves as the feed or the fertilizer or the energy source, the nutrient source for the probiotics to help them grow. And they're preferred energy sources. So they're not just feeding everything, they're feeding some of the more beneficial organisms in the intestine. The output from those probiotics is the postbiotics. And you know, we use the term excretion. It sounds a bit negative or dirty or whatever, but it's not. It's what these probiotics are doing as they grow and they transform different nutrients into other things that could have real beneficial effects on the host individual. And finally, the fourth area of biotics that we'll be talking about today is the subject of parabiotics, or some people call these para-probiotics. These are basically, you know, several decades ago, a man by the name of John Tyndall and others experimented with taking live organisms, deactivating them, but keeping the active components of them such that they could confer a health benefit to the animal. But these are non-living, so they're not going to replicate like probiotics, but nevertheless have some beneficial effects to them as well. So we'll talk about that area as well. All right, so let's get right into this. What are prebiotics? Well, they're basically non-living, non-digestible substances, which, as I mentioned earlier, are preferred energy sources to intestinal bacteria. And as a result, they can confer a beneficial effect to the host individual. I've listed several different examples for you, but the main thing I'd like to leave with you on this slide is that prebiotics help shift, in a general sense, the gut microbiota to being more beneficial or more advantageous to the host individual. Now, this next slide covers fructooligosaccharides, which is by far the most widely utilized and studied prebiotic that exists. You know, I've listed or I've shown to you different sources of these. The one I'd like to point out a little bit more is even a fungal, a food-friendly fungus is used to produce this in large quantities. So whether it's isolated from these different tubers or actually from the fermentation of fungi, you know, you can get it either way. All right, so many different names for FOS exist. Not only is it the preferred food by the beneficial gut organisms, but also it its production promotes a lot of lactic acid in the gut. And lactic acid serves as a general way of creating a more advantageous environment to those beneficial organisms. Said differently, pathogens don't like to be in a relatively acidic or lower pH environment, which is what lactic acid helps promote in that environment. Okay, and furthermore, the fermentation of FOS results in other things like SCFAs, and we'll talk more later about them, but they are preferred energy sources for intestinal cells. And finally, these prebiotics like FOS provide a mineral absorption benefit as well. Okay, what evidence exists in a broad scientific world? Well, there's many different in vitro or rodent studies, and even human, use the human as a model for these dogs, cats, and horses research, if you will, where they've shown immune benefits, even effects on metabolic syndrome like weight management, so forth, allergies. Autistic individuals even have been benefited by having FOS in their diet. So a wide range of benefits have been identified with FOS. Now, within our target species for today's discussion, the dog, the cat, and the horse, there are certainly beneficial movements in beneficial organisms in the intestine. That's been studied in dogs and cats. And furthermore, some of these more interesting things like improved insulin sensitivity, even in overweight horses, has been shown with fructooligosaccharides. And the other thing I'd like to point out is a really interesting finding many years ago, where we did research with FOS in combination with some other fibers in the intestine of dogs and cats, and found a shift in nitrogen excretion from going out the urine route to the fecal route. And why is that important? Well, in the case of a renal compromised individual, that could help lessen the burden of nitrogen excretion through the urine route by going through the fecal route. So many different, very interesting effects of the prebiotic FOS have been identified in our target species for today's talk. Okay, is it only FOS that's been studied? No, there are other prebiotics such as MOS and GOS. To set this up, man-anoligosaccharides, and GOS also promote a favorable microbiota shift, but they do it through different mechanisms. MOS is quite interesting in that it has a binding site or creates a binding site for pathogens to hold on to, if you will, and get flushed out with the other fecal contents. That's important because whether it's a pathogen or a beneficial organism, it seeks to glom on to something to become what we would call a resident organism. And the alternative, of course, is to glom on to the intestinal environment. And certainly, we don't want the intestinal lining to be colonized, if you will, by a lot of different pathogenic organisms. So that's what the MOS does, is it provides a competitive binding site, if you will. GOS, the thing I'd like to highlight about that, interestingly enough, is used a fair bit in human infant formulations. And did you know that mother's milk actually it has as a component of it oligosaccharides and glycoproteins and these sorts of things that promote the growth of some of the best beneficial organisms in the intestine. And so when we put GOS or FOS, that's also used into an infant formula, we're actually helping promote the growth of these beneficial organisms at the expense of the pathogens. So interesting side note. All right, so what are some of the evidences or data that exists in our target species, dogs, cats, and horses? Well, MOS certainly has been shown to shift populations of intestinal bacteria in the right direction, while in cats, there's actually been some evidence to suggest that nutrient digestibility is improved. A final thing, without going through each one of these areas, there's certain immune benefits that have been but I'd like to point you to glucomannan-oligosaccharide, which is a very interesting study years ago, where it was actually shown that there was some binding of grain mycotoxins. So mycotoxins are present when a fungus inhabits like a small grain like wheat or even like corn, where it produces a lot of toxin and it gets mixed in with the food. And unfortunately, the toxins are detrimental to the host. But in this study, they showed a benefit, in this case to horses, to decreasing the toxin load. Now, of course, no reputable manufacturer would want to purposefully formulate that into their products, but accidents happens, and sometimes even pockets within the grain loads that are coming into the plant vary. And so it's just interesting to me that perhaps an opportunity to further innovate, our companion animals diets is to put in some of these, very interesting molecules that could bind toxins. All right, so let's shift into the realm of the living organisms, the probiotics. I've listed for you first and foremost on this slide several different names of these, but there are myriad of different strains and types of probiotics that exist. These are perhaps some of the more common ones you probably recognize even from a container of yogurt you ate this morning, seeing that on the label. Some of the benefits of these are certainly like prebiotics to move the microbiota population, to shift them, but it does it differently, of course. It's the seeding, it's the purposeful introduction of these beneficial organisms that probiotics do to move that microbiota in the gut. There are certainly immune benefits. Each one of these areas, I try to segment it out for purposes of the discussion, but there is certainly overlap in terms of the benefits, immune modulation being one of them. The one thing I will point out, though, is as we talk about probiotics, some of the systemic benefits are more well characterized in probiotics. Certainly there does exist that literature in the prebiotic as well. But I want to take the point in this presentation to highlight the fact that the probiotics can shift the gut populations, but confer other health benefits beyond the gut, and talk to you about the gut-brain connection. So we'll do that in a moment. First of all, let's talk about the immune benefits. You know, I'm throwing out that big term about immune boosting or immune modulation or whatever. Well, what does that mean, and what exactly is going on? Well, let me highlight this to you with 4 different modes of action I saw listed in the literature, and there's probably a few others, but these are big reasons why the immune system is generally benefited, in this case by probiotics. Number 1, from an indirect benefit, it lessens the allergenic response by improving tight junctions. Okay, so if we think of the intestine as like analogous to a garden hose, but that garden hose is semi-permeable on purpose to allow nutrients to be absorbed and get into the bloodstream. It's called translocation. Move those individual nutrients into the bloodstream. That's all well and good. However, if that garden hose is too leaky, then other things that are unwanted, such as bacteria, can move from the lumen, the interior of that garden hose, into the bloodstream. And that's a problem, right? Not only is it not good for pathogens to translocate, many times the beneficial organisms can also have detrimental effects if they move across. So if we improve the tight junctions, as they're called, of the lining of the intestine, will decrease the chance, these bacteria moving across and thus setting off the immune response associated with that. The second indirect way is as a part of that protective mechanisms, there's also mucins that are secreted to help create a barrier to that lining of the intestine. And not only the amount of that mucus can be affected by the probiotics, but also the types of the mucus can be affected, thereby improving the barrier function. And a third way, indirect way, that probiotics can improve the immune function of the intestine is to compete for binding sites on the intestinal cells, right? So as I described earlier with MOS, if we have a lot of probiotics residing on the lining of the intestinals on the luminal side, that'll certainly prevent other unwanted pathogens from setting up their toxin being produced, and they're offsetting or increasing the immune response. So 3 indirect ways. The fourth way that I saw in the literature that I wanted to share with you is a very direct way in that probiotics secrete bacteriocins. Bacteriocins, I like to say, are like a heat-seeking missile. I mean, they're very targeted. It's just not a general negative bomb going off, if you will, in the intestine, but rather these probiotics secrete bacteriocins that go out and they hurt or they kill off, frankly, pathogenic organisms, which thereby decrease the risk of pathogen infection and thus improve the immune system of the intestinal environment. All right, so I've been throwing out this gut-brain axis. You may have heard it talked about. It's a really cool term. Well, what exactly does it mean? Well, first of all, I'll throw another cool term at you, psychobiotics. And it's, folks, it's just amazing. The amount of research that's coming out in the world of psychobiotics is profound. But let me come back to the modes of actions. First of all, the probiotics are known to affect the regulation of neurotransmitters and proteins, which are important to brain function and brain signaling. The second way in which the psychobiotics or probiotics that affect the gut-brain axis is that they play a role in the hypothalamic pituitary adrenal axis, or HPA. And Ted Dinan, who's a very progressive researcher in this area, and a colleague of his at University College Cork, they characterized gut bacteria influencing the vagus nerve. So if you look over here on the side of this graphic, you'll see the vagal nerve connecting from the brain to the gut organs there, the intestine, and influencing that is very possible through these psychobiotics. And a second function that they also have noted a lot is the fact that probiotics themselves secrete hormones. Let me say that again. Probiotics are actually known to secrete hormones. Yes, so they can actually feed back to the brain itself through influencing what they secrete in what we will call for this presentation postbiotics. We'll get a little bit more into that, but all these 3 mechanisms wrap together to give us the gut-brain axis, or the psychobiotic mode of actions, if you will. All right, so let's go on then to talk further about probiotics and what their benefits are. Certainly, there are anti-diarrheal. Probably you've all heard of that, and the underpinnings of immune modulation and inflammation management, and those are tied together. If you've heard that before, but immune and inflammation are basically tied together. It's another talk for another day, but it's part and parcel. During gestation, there's a study that I came across where perinatal vitamins were actually present at higher levels, thus perhaps decreasing the chance of having birth defects in utero as the fetus is developing. And finally, many different mood and cognition studies. Again, like I said, and perhaps, unfortunately, the scourge of many countries around this planet is related to the drug use and so forth by society. And as a result, governments have realized that it's important to pour money into researching this. And what better way to do it other than through a natural means like a probiotic and what they can produce. So tons of research are coming out, very recent research. So it's definitely a significant effort around the world from what it looks like through the literature. Okay, and finally, to wrap that part of it off, I wanted to throw into this, these are specific diseases or disorders of the human related to psychofunction, if you will. But make no mistake, there's not a pet owner that I've ever come across that isn't concerned about the behavior of their pet, whether they're smart, are they trainable, do they have good cognitive function, and so on. So I think a lot of this research, although it's going against the human area, I, again, will say the human serves as a great model for what we're going to learn and be able to reapply to these beloved, horses, dogs, and cats, these companion animals. So, all right, at this point in the presentation, I thought it important to share with you, probiotics are not just bacteria, no, but they're also yeasts are involved. And Boulardii is a very well-studied yeast for human as well as animal health. And there are several different mechanisms, one of which I would like to highlight to you is just the fact that they act a bit like generals in the population of microbiota in that they crosstalk with normal bacteria. And it's like, come on, get in shape, do your job. And so they really serve to round out what's going on in the intestinal environment. And they fundamentally, this Boulardii has been characterized to impact immune response and inflammation in a very positive way. From an efficacy point of view, there are tons of studies looking at different types of diarrhea in the human population, as well as managing colitis and infectious pathogens in the intestinal environment. Okay, so the other thing I thought is important to highlight is the microbiome, or how the microbiota interact within the intestine of the horse. And the horse is like dogs and cats and humans in that it is a monogastric. It's not like a cow where it has pregastric fermentation. But in contrast to the dog, cat, and human, it has a very active hindgut fermentation, much more so than we do or dogs and cats do. So it's the microbiome, the physiology of the horse is a bit different that way. And for any one that's been a horse owner for any length of time, they come to learn and realize that things like colic or laminitis or acidosis are very prevalent in these animals, systems and situations. And so it's important to highlight that because of the huge amounts of energy that's derived from the forages that are ingested by the horse, that managing the microbiota of the cecum in particular is very important to maintain good function of that animal's digestive tract and to perhaps avoid some of these other issues. And indeed, to round this out, I'll just share with you that relatively low levels of a probiotic yeast have been shown to give great benefits. Foundationally, I would say to all of this is improvement in fiber digestion. And that's without question that many studies have been shown to substantiate that. But furthermore, this sets up that ecosystem to have less dysfunction perhaps in these areas of acidosis, laminitis, and so forth. All right, so now we're going to transition into the third area of the biotics, which is parabiotics. And as I noted before, you might also refer to these as para-probiotics, okay? To definition it out for you, if you will, these are non-live, so they're not alive anymore, microbial cells or extracts, which then are used to confer a health benefit to the consumer of those inactivated cells. So you'll see this out in the marketing world of these are ghost cells or zombie probiotics or whatever, and certainly they're catchy terms or whatever. But generally, usually what they mean by that is that they're basically non-replicating or inactivated cells. Again, they may be referred to as para-probiotics as well. The deactivation can occur by several different means, but the most widely one that I'm aware of is really heat deactivation of these probiotic strains. They're heated to a point where they can't replicate anymore, but they still have some of the active aspects of those probiotic organisms in them. Let me give you a little bit more detail on this. You know, it's been characterized considerably. There's a lot of research in the scientific community over what are some of the potentially beneficial components of the cellular membranes, and things like peptidoglycans or teichoic acids, surface proteins have all been shown to have beneficial effects to the host individual. You know, whether it's strengthening tight junctions or improving the epithelial barrier properties and so forth. A lot of good benefits, but you know that under certain situations, those cellular membrane components may not be available in a living organism, but rather if it's deactivated and perhaps heat treated a bit, it'll be even more available. And indeed, that's what Zhang found in a recent study where these researchers compared Lactobacillus plantarum in either a heat-killed or deactivated form versus the same strain of bacteria in a live form, and found that actually the heat-killed plantarums were more effective in this case with conferring anti-oxidative benefits to the host individuals. So, you know, at least there's a little bit of evidence showing that, hey, some of these para-probiotics may be even better than probiotic version of itself. Okay, at this point in the presentation, I thought it would be worthwhile sharing with you this canine-based study that I came across, a relatively recent study, very well done, I might add, with some really interesting findings. It is what I would characterize as a parabiotic, postbiotic combination. So just keep that in mind, because they had not only residual yeast cells and yeast cell wall fragments, but also fermentation metabolites and other components of the fermentation growth media. You know, from a research or a production standpoint, it's really difficult to separate the two. So they're all kind of mixed together. But note that at relatively low dosing levels, within what I would consider a relatively quick turnaround, within a month period of time, researchers were able to characterize improved gut health by microbiota shifts in a favorable fashion, and as well improved immune response, not only at the level of innate immune response, but also at the level of adaptive immune response within these animals. So that's a pretty interesting finding by these researchers, I thought. Analogous to that is another different source, but nonetheless also a parabiotic postbiotic combination where researchers were using, in this case, a Delbrueckii fermentum combination, feeding it to healthy mice and finding that these healthy mice had increased sociability, lowered steroid hormones, stress hormones rather, and minor but important gut microbiota shifts. So in this rodent model, they were able to show perhaps that in reality actually, that a biotic blend here, if you will, improved the mood situation of that individual. Okay, so let's go into the fourth and final area of biotics that we're going to talk about with you today, that being the postbiotics. This, as I said earlier, is basically the output of the probiotics that then are used to improve the host animal health when those postbiotics are ingested or available, at least in the intestinal situation. Okay, so I've listed for you several examples of these postbiotics. I've talked earlier about SCFAs. We'll share a little bit more detail with you on those. Certainly different vitamins, peptides, bacteriocins, neurotransmitters, and wow, this list is getting long. Yeah, and look, if you will, in the English language, these are plural. Yes, there's not only tens, but there's literally hundreds of these different postbiotics that have been characterized. And I would even go so far as to say, I don't think we've fully characterized all of these postbiotics that really are being produced as a result of these different bacteria or yeast or what have you in microbiome systems. So to me, I'd like to say that, postbiotics is real science available today, and we'll highlight some of those findings. But folks, I really believe that we're at the beginning of the S curve of where this whole area of research and science and ultimately commercial value is going to come out of in the postbiotic realm itself. Make no mistake, we're going to learn more about probiotics, we're going to learn more about prebiotics and so on. But as time goes on, postbiotics hold tremendous promise because of some of the ways in which they can be produced and some of the compatibility with end product formulation as well. So, as an industrial scientist, I try to look at this not only from the point of view of the science and the academic progress that's being made in these areas, but also in terms of, well, could this be commercialized or not? And I am really excited about the postbiotic area, to be very candid with you. Let's take this a little bit further in terms of characterizing what's meant by postbiotics. Even the supernatant, which is the fluidized portion of these tubes, you can see that with that arrow there, as opposed to the darker area, which represents the pellet or the solid fraction being spun out through centrifuging. And that clear area, although it looks clear, is rich, can be very rich in many different active components. Things like hydrogen peroxide or hydrogen sulfide. I mean, we've done this research, folks. I mean, I worked with folks trying to understand how can we improve food stability and food, preservation and being able to deal with foodborne pathogens. And let me tell you, hydrogen sulfide is a very potent molecule against mold formation, and it's an antimycotic. So whether it's antimycotic, antibacterial, anti-biofilm, and we don't have time to go into this, but there's a lot of applications even on one's teeth in the oral cavity. Biofilm formation is a very problematic situation that occurs, as well as things like inflammation and, dare I say, cancer benefits. I know that's a bit taboo in the world of nutrition and, it's not regulatory friendly, but it is what it is. Nature goes on regardless of how we define things, folks. And there are some anti-cancer benefits that have actually been attributed to postbiotics, but let's not keep going too deep on that one at this point. Let me just come back to a specific area of postbiotics, bacteriocins. Bacteriocins, as I said before, are antibiotic-like substances produced by the bacteria themselves. What's not to love about this? This is natural-born antibiotics. This is not something synthesized, man-made. It's nature-derived antibiotics, if you will, that are very targeted against pathogenic organisms, things that shouldn't be there, by virtue of the things that should be there, the beneficial organisms, the probiotic type of organism. And there's a pretty good amount of research around this area and actually commercial products. So this is not like just academic stuff. This is real world applicable stuff, especially in the world of natural, what I'll call natural biopreservatives. Nisin and a fermentate of a probiotic organism are both commercially available because they've been reviewed and approved by organizations in the regulatory community. So real world applicable, technology. And SCFAs, okay, if I wouldn't highlight the benefits of SCFAs, those that know me and my background and some of the research I've done through the years would wonder why. But it's just foundational. It's almost like so obvious. I think about this and I need to spell it out. Short chain fatty acids are profound energy sources for the intestinal lining. They are preferred, actually preferred over typical carbohydrates like glucose that would be normally ingested. The lining of the intestine has been adapted and designed to utilize those entities preferentially, and they all come from fermentation or breakdown by the organisms inside the intestine. But it doesn't stop there, folks. This is a long-term area of research, and I highlighted one on the left, and I'm not going to go into the detail. All the verbiage is there for impact factor only. But butyrate itself, just one of these SCFAs, has profound effects, both in the intestine and outside of the intestine. And I'll just say this, that, years ago, we were working with dogs and showed, that prebiotic FOS could produce these SCFAs in the large intestinal environment, and it had profound effects in terms of shifting, or rather creating hormones that resulted in improving insulin secretion and finding improved glucose tolerance to the ingestion of a meal. That was years ago, and this science has continued to progress and evolve and so on. So the production of SCFAs, really, the value to the host animal cannot be overstated, in my humble opinion to you. All right, so with that, we've taken you through some of the depths, if you will. You've stayed with me on the submarine in the depths of the ocean here of knowledge. We're going to periscope up a bit, if you will, to some applications. And I want to characterize this in the three main buckets of life and the times in which we all live and our companion animals live as well. During the young life, that individual is born relatively sterile, not quite, but relatively sterile. And within hours, that intestine is becoming infested, if you will, by many different bacteria and yeast and fungi and so forth. And it's so critical, folks, that time in which the intestine is evolving and changing and developing and so on is done in a manner that's healthful to the animal, not hurtful. And that continues through the oncoming weeks and months until that animal becomes mature, generally at about a year of age, if we're talking about a dog, cat, or a foal. And during that time is a tremendous amount of infection risk. Hey, whether you're breeding, the next generation of extreme, competitive horses, or you're a breeder of kittens or puppies, you realize that the risk of infection, scours, diarrhea, and so forth is very great. And so, we want to use these biotic tools, as I call them, to influence that microbiome system in a very helpful, healthful fashion. And again, because this animal is now ex utero, outside of the mother, it has to develop its immune system on its own to fend off infectious agents. And so that's really foundational during this period of time. Okay, then of course the animal becomes a young adult, relatively healthy, strong, high of its life, whatever. Do we really need to be concerned about the microbiome at that point? Well, certainly we do. Just because it's a healthy adult doesn't mean it's going to, not have environmental stressors, risks of infection, and so on. And it all backdrops. It's so easy for me to talk about this, coming out of the year of COVID, an infectious, agent in our own, human environments and human situations. Dogs, cats, horses, they all experience that, even though they're relatively young and healthy adults. A couple of areas to highlight here is oral. I mean, some of the pet supplements we manufacture, we've seen anecdotal benefits identified to us about, wow, the teeth really look clean or whatever. Well, It's partly due to the type of product we manufacture. It's powder, so it's probably resident a little bit longer, and it's enriched with probiotics as well as other biotics that are probably shifting that microbiota in the oral cavity itself in a more beneficial fashion. And from a weight management perspective, there are certainly many studies that have been shown, primarily, to be fair, in orientation to the human and other models of the human, but nevertheless, that the type of microbiota present seems to be correlated with whether or not that individual has a healthy weight or not. So there's a tremendous amount of work and development going on there. And I just got to say, at this this juncture in the presentation, I'm aware of a postbiotic, folks. It's a probiotic postbiotic combination, and this company is marketing this stuff. So it's real world science that it is actually has been shown to improve the satiety of the individual. The single biggest disease condition of the human actually is being overweight, not underweight, but actually overweight. And people are using a postbiotic to influence satiety in individuals. Wow, that's profound. And that's just that one single example of a postbiotic. But I digress. But let's move on to the third area of life, which we all hopefully will go through, of course, and that's becoming older, becoming a senior individual. And like us, our pets do as well. And as time has gone on, we've lived a long, good life and all that, the oxidative stress, the continued battling of different reactive oxidant species hits our DNA, our pet's DNA, and attempts to break it down. And of course, what happens? Well, we get cancer or tumor formation occurring because the DNA has gotten corrupted, if you will. So there's ongoing oxidative stress that senior animals come up against. Certainly, like any other stage, they're going to deal with inflammation management, but most pointedly, I would point out to you mobility, whether it's a horse or a dog or a cat, human being for that matter. We all struggle with more mobility issues as time goes on. And what better tool than to consider the biotics, the microbiome agents, if you will, that we can use to manage that more effectively. And finally, the oral care area, certainly as pets age, it gets more challenging to deal with. And so, I'll just point out, if plaque forms, gingivitis and tartar and gingivitis can ultimately set in, wrecking the gums around the teeth, making them more susceptible, if you will. And if those bacteria in the mouth, good, bad, or otherwise, translocate or get into the bloodstream, they float around the bloodstream and they can infect the kidney area. And, especially in the cat, there's a lot of literature that describes, renal failure in cats. And, some of the progressive researchers in this area really attribute, just the poorer oral health due as a reason why these bacteria get in and ultimately wreak havoc with the renal system. All right, so then let me transition into an example of the microbiome enhanced, in this case, dog food. I suppose you could make this a cat food or whatever with some minor modifications, but look, this is not a commercially available food, something that yours truly just made up. But let me tell you that tomorrow we could go to a manufacturing plant and make this. This is very feasible. And I've represented it perhaps in the format of US regulations, AFCO in particular, but this could also be marketed, in a similar fashion in a European environment, which has a different set of regulations that would just appear a bit differently on the label. But anyway, it consists of prebiotics, probiotics, postbiotics, and para-probiotics, all contained within this food example. So this could be done. I mean, and we could design a food to be more microbiome advantageous by enriching it with these different biotic sources that we've talked about today. Analogously, I put together a supplement. In this case, it's a soft chew format where we load in some actives, many of which are biotics, could be marketed as a biotic, healthful, digestive, active, enriched, chew, what have you. And many really cool claims could be made off of this. So really a very functional, healthful treat that could be given to companion animals. All right, to round out this discussion, I'd like to share with you two tables, all of which have the same format. It's what I call the comparison of the biotics. And along the left, I've got different attributes of them. And of course, across the top are the different biotics. I won't read you all the examples of these, but hopefully many of these are starting to come to light as we have talked through the presentation. To characterize some differences between them, let's go on then. The live organisms would be the probiotics, whereas the rest of them are not. Those that are derived from live organisms would be everything except for the prebiotics. Again, prebiotics being the feed, if you will, the nutrition, the energy source for the probiotics to grow and so forth. As far as do they provide nutrients for the live organisms? Well, certainly, you know, as I just said, the prebiotics do, and sometimes the postbiotics do that as well. So lactic acid, I was talking about earlier, can be converted into propionic acid. So it can be reused, if you will, by other organisms in the microbiome system. And finally, gut actions. You know, again, we've characterized probiotics being a bit like a starter culture, if you will, for beneficial gut organisms. Whereas, you know, prebiotics tend to be nutrients for those beneficials. Parabiotics, kind of a highlight to them is cellular components, which are quite active and healthful to the animal. And finally, postbiotics, doing a myriad of different things. I've just given you a couple of them: inhibiting pathogen growth or providing intestinal cell nutrients and so forth. Okay, so looking at some advantages of these different biotics, the probiotics can be quite cost effective because they are replicating, you know, they're reproducing themselves. And so it's like you put a little in and it continues to, you know, multiply and amplify its own benefits. But in contrast to probiotics, the other biotics generally are more stable in dry food forms. And so, you know, that's the challenge we run into, a disadvantage, if you will, with some of the probiotics, many of the probiotics not being stable in some of the commonly available food forms. But, you know, again, it goes to what exactly that food form is. So there's potentially some more technical work that needs to be done, or better handling, or better packaging, and so forth. The other disadvantage that I would point out in the world of prebiotics is they're very hydroscopic. It's not untenable by any means, but it just requires some education of plant personnel, people that are handling those prebiotics, to make sure they're stored and handled properly when formulating and producing food forms. Finally, from a safety point of view, one of the things I really like about Lallemand is they work very diligently to characterize probiotics, and I'm sure other companies do as well. But that's something you would want to ask: is, you know, do your probiotic sources have antibiotic resistant genes in there? Because unfortunately, these probiotics have a way of swapping genetic material, and certainly we don't want to you know, indirectly introduce something potentially negative into the intestinal environment. The other thing I've seen from the literature is under extreme conditions, you know, unfortunately, many of us have loved ones or whatever that have dealt with cancer, and with a lot of radiation and chemotherapy, you know, the immune system becomes basically wiped out. And in those cases, I've seen enough literature to suggest that it's probably a bit risky to put a probiotic, a living organism, into those individuals' system. But other than that, you know, probiotics are generally healthy in under many different conditions and diseases and so on. So, all right. So I don't see a lot of other risks with the other biotics that I would like to bring out at this point. So with that, I'd like to say, in the native tongue of Lallemand, merci. And by the way, Lallemand, thank you for setting this up. Really appreciate that. To you all, I'd say in my native tongue, thank you. And in my forefathers' tongue, Norwegian, I'd say tak skul da ha. So thank you for staying with me. And this is our house dog, Millie. We're thanking you together, I guess. If you liked anything of what you heard today and you want to hear more, follow me on microbiomenexus.com. That's my personal blog. It's not just about me. You know, I read the literature, and when I see things that I think are really progressive and whatever, I cite it, I talk a little bit about it, and I post it so that, you know, maybe it highlights it a little bit more for the rest of you. So again, thanks to all of you for your time today. And I guess at this point, we will turn it back to the moderator and have a bit of a time of questions. So, all right, thank you.